Now you tell me the steps. I'm gonna do it on the board. Okay. You'll have to tell me the steps now. Okay, so let's start with the condition when the switch was closed. Okay, when the switch was closed, that means the time was less than 0. So it's gonna be short circuit over here. So we are gonna have the current is gonna come through here, and it's gonna bypass this resistance. Then it's gonna come through here and here, right?
And that inductor also short circuit.
And then this inductor will also be a short circuit. Okay, this is a steady state condition. It is said that it is a steady state condition before the switch was open. So we are gonna have, what will be the current value? Huh? The current value will be 1, okay. 1 what? 1 amps, okay? Alright? Okay. And then what would be the voltage value? The VT? The VT will be 0, okay. Alright. How did I get 1 amp? Okay. So, the idea is, once the switch was closed, okay, the current is going to be generated from here, then it's going to come over here, and then it will always take the path of least resistance. So, instead of going through this path, it's going to go through the other way around. So, it's going to bypass this resistance. And then it's going to see only one resistance, that is 100 ohms. And finally, since this was a steady state condition, so the inductor will also be short. So all resistance that is gonna, the only resistance that the current will feel is the 100 ohms resistance. So the current that will flow through the entire circuit will be given by voltage over resistance. V is equal to IR. So I is gonna be V over R. V is 100 volt, resistance is 100 ohms. So the current will be 1 amps. Okay? Make sense?
Yes.
Alright. Now, let's come to the point when the time is not 0 anymore. Okay? So as soon as the circuit opens, then we are going to have some profile, right? Let's try to write the KVL, KCL, whatever. I mean, you will have to write both in fact. All right. KCL, okay.
We combine the resistors first.
Yes, you can. Of course, you can combine the resistances. That's fine. Okay. Now, if we do the KVL, then we are going to have, what's going to be the KVL equation? Start from here.
Minus 100.
Negative 100 plus 100 times I, okay, plus 100 times I. If you combine the resistances, it's going to be 200 times I. Same thing, okay? Yes?
Current is a function of time?
Say again?
Current is a function of time?
Yes. Current will always be a function of time.
Which is IT or IT?
Yes, you can write IT, but you know, since I'm writing on the board, okay, I'm in a big mess now. So that's why I'm just trying to, minimize my effort. Being lazy. Okay? So 100 plus 100 times I, then what else? Plus
VT.
So what's gonna be VT? Okay. What is VT?
0.
Not at this point. It's not steady state anymore. It's not 0 anymore. The switch is starting to open.
DI over DT.
L di over dt. L di over dt. Exactly. L di over dt. Okay. That's gonna be equal to what? 0. Okay. Now we have L di over dt plus we have 200I, it's gonna be equal to 100. Then what do we do?
Set up I equals
We assume an equation for I. What is that equation? K1 plus K2 e power st. Okay? So the equation becomes L, then K2s e power st plus 200 K1 plus K2 e power st. That's going to be equal to 100. Okay? So then what do? We equate the coefficients, right? So L K2s plus 200 K2 e power st plus 200 K1, it's going to be 100. Then
solve for K1,
solve for K1. What is K1 then?
0.5.
K1 will be 100 over 200, okay. So it's going to be 0.5. Does everyone get this?
No.
No?
Sorry, can you go over again to why you get rid of the LK2S? You said you...
Okay. So once I am assuming an equation for the current, then I am going back to this equation now. So I am just differentiating this equation, okay, multiplying by
that.
2. So what will you get if you differentiate this equation?
The K2SE ST times L.
Uh-huh.
Oh,
So that's what
yes,
you're gonna
I have that problem. I'm finding how you equate both sides to the second.
Okay. So equating both sides means the constants will be same as the constants. The e power will be same as the e power. So what we have on the right hand side is 0 times e power st. So that's why the constants will be equal to the constants. The e power will be equal to the e power. Okay, so we are going to have LK2S plus 200K2. That's going to be equal to 0. Because we are equating the powers. And we will follow the same thing in the later classes when we start doing the particular solution and complementary solution. Okay. Now what we have over here, what value do we have from this equation? S. Okay, how much is S?
Negative 200 over L.
Negative 200 over L. Okay. Negative 200 over L.